Hey, what's up? This is Randy. Today we'll learn how to identify various forms of both square root functions and cube root functions. Here we go. So we're going to start today by looking at what we call the parent graphs of square roots and cube roots, and then we'll have a discussion about the basic transformations of these graphs that we could see. And then finally, we'll do some examples. So first, we're going to look at the parent graphs of both the square root of x and the cube root of x. And then we'll look at the formulas below, that is this formula right here and this formula right here, which will guide our understanding of the transformations that we could see. So quick observations. The starting point of the graph of the square root of x is at 0, 0, and then it passes through a point that is 1 unit up and 1 unit to the right of that starting point. In this case, that next point is 1, 1. Now with the cube root of x, the point of inflection is at 0, 0. That's where the slope changes from increasing to decreasing. So that point right there is the point of inflection. And the graph also passes through a point that is 1 unit up and 1 unit to the right of that point of inflection. So 1, 1. It also passes through a point that is 1 unit down and 1 unit to the left of that point of inflection. All right, now real quick, let's compare the first quadrant of the square root of x to the first quadrant of the cube root of x. You'll notice that both of these parent graphs pass through 0, 0 and 1, 1. And you might initially think that the first quadrant here and here is exactly the same. That is that the curve travels on the exact same path, but they actually don't. If you zoom way out, you'll see that this graph travels on a slightly higher trajectory than this graph. All right, now I'm going to let you read on the screen about the types of transformations that these graphs could undergo based on these formulas, and then we'll talk about each one. Now, these rules of transformation apply to both square roots and cube roots, so that's why I put both the equation for a square root graph and the equation for a cube root graph here on the left. Now, I encourage you to pause it so that you can read each of these and do your best to process this information, and then we'll talk about it together. All right, now that you've thought about it, let's talk about each of these types of transformations. All right, let's start with the variable a. What does a do to the graph? If a is between 0 and 1, it will cause the graph to be vertically compressed. That applies to both square roots and cube roots. If a is greater than 1, it causes the graph to be vertically stretched. Once again, that applies to each type of graph because all of these rules for transformation apply to both square roots and cube roots. So if a were 1/2, for example, this point right here would move to right there. If a were 2, that point would move right up here. Now on the cube root graph, if a were 1/2, this point would move to 1/2, and this point right here would move to -1/2. And if a were 2, for example, those points would move to 1, 2 and -1, -2. So the graph will be stretched vertically. All right, now let's talk about h and k. H is the counterintuitive shift and k is the intuitive shift. So we'll start with this part of the formula, minus h, which we know that in some cases could be plus something. So let's say that we had minus 2 in place of minus h. That counterintuitively would shift every point on the graph 2 units to the right. Okay? Now, what if we had plus 2 instead of minus 2? Well, as you would probably expect, that would shift every point on the graph 2 units to the left. All right, now let's say in place of plus k, we had plus 2. Now, the direction of the shift of k follows our intuition. So plus, you probably think would be up, and that is correct. So if plus 2 were in place of plus k, that would shift every point on the graph 2 units up. And if we had minus 2 in place of plus k, that would shift every point on the graph 2 units down. All right, now let's do some actual examples. All right, now, because I'm a nice guy, I decided to give you guys this guide right here, but I encourage you, as you keep on doing these problems, to try to use this information less and less, and instead have it internalized, okay? So we need to identify the equation of the graph given. Looks like we have a square root graph that is shifted. Now, is this graph also scaled? Well, we can see that the starting point is right here at 3, 2, and then it passes through a point that is 1 unit up and 1 unit to the right of that starting point. So that tells me that this has not been stretched or compressed. So A is 1 because this has not been scaled. Now, if you didn't already pause to try this yourself, make sure to pause it before I continue. All right, because we know that this has not been scaled, it has not been stretched or compressed, we can eliminate any options that have a value for A that is not 1. So here we have 0.25 for A, and here we have 2 for A. So the answer could not be A or D. Now let's choose between B and C. Which one does it need to be? Well, we know the starting point of the parent graph is at 0, 0. So this graph was shifted to the right 3 and up 2. So a rightward shift tells me that we need to have a minus h. So it looks like B is going to be the answer because we have minus 3 in place of minus h. And an upward shift tells me that we're going to have a plus k, which applies to both B and C. But because we have minus 3 only in B, that needs to be the answer. Just so we're all clear, this plus 3 would indicate a shift to the left 3 units, but we know that this graph is shifted to the right 3 units, and of course up 2. All right, let's do another. All right, so once again, we have clearly a square root graph, but look at how incredibly compressed this has been vertically. This is definitely vertically scaled. So immediately, I know that we can eliminate B because B is a cube root. And because this graph has been vertically compressed, that tells me that A is going to be between 0 and 1. In this lesson, we'll just be dealing with positive A's, okay? So what is the value of A in option A? Just 1, right? We can see that there's nothing in front of that square root. What is the value of A in option C? 4. So A and C do not look like the correct options because we need an A that is between 0 and 1. And you can see that option D has 0.25 for A. So that 0.25 for A clearly shows us that option D is the only one that indicates a vertical compression. And the shifts also line up perfectly because this plus 1 tells us to the left 1, and this minus 2 tells us down 2. And we can clearly see that the starting point of the parent graph moved from the origin to the left 1 and down 2. All right, let's do one more example. All right, this time we have a cube root graph, and the point of inflection is at 2, -3. And this graph has clearly been vertically stretched. So that tells me that the value of A is more than 1. Here in the options, we have a value of A that is 1, value of A that is 1, right? There's an implied 1, even though it's not written, and a value of A that is 0.5. So B, C, and D should not be the answer. The answer should be A, because we can see that A in option A is more than 1. It's 2. And this minus 2 in place of minus h tells us that it should move to the right 2, and this minus 3 in place of plus k tells us that it should move down 3, which is exactly what it did. And that's it. Now we know the answer. All right, and now that we can identify the basic types of transformations for both square root graphs and cube root graphs, we are finished.